But we didn't. And the time, if we should have already discussed this. The time of flight for a ball that's just dropped to some location here, to this location, the time of flight is going to be equal to the time of flight of a ball being shot out and it eventually falling down at this location. So the time of flight between these two events will be the same. So if I draw this ball is coming down like so, and this ball is just going straight down. So I'm just saying that the time is the same. If that is the case, we can just use our y equation to generate the time of flight. So here we go. Remember, yf minus y initial equals to the initial velocity times sine of the angle theta times t minus 1/2 gt squared. Now, the angle happens to be 0 degrees. Therefore, sine of 0 degrees is 0. So that means that this entire portion here will go to 0. 0 times anything is 0. So we end up with a simpler equation. The displacement in the y direction is just equal to the product of a negative 1/2 g and t squared. So in this particular equation, we're actually looking for the time. We're not just going this way just because, but we're looking for the time. And why is that? It's just a technique that we're using. Of course, you could probably use a stopwatch or many other ways to do this. And so the time is just going to be, and let me make sure that I'm on this pen. The time is going to end up being t squared equals to negative 2 times the displacement in the y direction divided by g. And this is going to imply that t is just equal to the square root of the negative 2 yf minus y initial divided by g. So all we need to know, we know what g is. G is equal to 9.81 meters per second squared. And we need to be able to calculate or measure yf minus y initial, which is just the displacement. Measure the displacement for the ball. How are we going to do that? Well, we're going to use video physics here. And we want to, let me see if I can pull up a good picture. This is good. We are going to, this is, that's the wrong color. Let me see if I can come up with a better color. Orange seems to work really well. This is x. This position here. These are our initial x's and our initial y's. These positions here are final x's, our final position in x, and our final position in y. So we mentioned delta x before, and we know that this is just our final position minus our initial position. And we also mentioned delta y. And this is just our final position in the y minus our initial position in the y. And we have those two equations, if you remember, that we're going to use. xf minus x initial equals to v initial times cosine of theta times t. That was one equation. And then we had another equation equals to v naught sine theta times t minus 1/2 gt squared. Okay? So I would say that, oh, this is pretty clear. But I bet you it's not super clear to you. Look at this. This is our our x displacement. It's coming from this value. Here's our y displacement. It's coming from this value. And what are we trying to calculate? Our initial velocity. What is our launch angle? Our launch angle is 0 degrees. Let me do this again. Our launch angle is 0 degrees. So we know this. We don't know time. We're going to calculate time from the y equation. And the whole idea is to calculate the initial velocity. Again, sine of theta, sine of 0 is 0, so this piece is just going to go away. We know gravity, and that's it. So this is the theory matched to the experiment. So now let's just go to the experiment.